In the first section of this chapter, we talked about the six trig functions: sine, cosine, tangent, cotangent, secant, and cosecant, and how to find those from a right triangle. And those 6 formulas are listed in the box at the top. And then last section, on section 9.2, we talked about how to draw different angles, angles that are less than 0 degrees, in other words, negative angles, and how to draw angles that are greater than 180 degrees on a coordinate plane where you would spiral around the coordinate plane. We're going to combine those sections together to talk about the trig functions for general angles when they're larger than 90 or possibly negative angles. Let theta be an angle in standard position, and using P, X, Y as a point on the terminal side, using a Pythagorean theorem, R equals X squared plus Y squared, the 6 trig functions of theta are defined below. Now, that can actually be better summed up as saying that what we can do is draw our angle here. There would be our initial side, there would be our terminal side, just like we learned on last section. And you can see the arrows going counterclockwise, showing us that we're drawing this to the positive for positive angles. What we can do is that we can draw a reference triangle and make a reference triangle by drawing from a point, and actually any point on the terminal side, straight up, in this case, back to the x-axis. And if it was above the x-axis, we would draw it straight down to the x-axis. And by drawing that reference triangle, we can use the measurements from that reference triangle to figure out the measures of the 6 trig functions. So here's an example. So example number 1 says the terminal side of theta in standard position contains the point at -3, -4. Find the exact values of the 6 trig functions of theta. So the first thing I'm going to do is draw what it's describing there. So let me draw a set of axes. And it says the terminal side contains the point -3, -4. So the point -3, -4 would be right here. So my terminal side goes through that point. And if this is my initial side right here, this is what my angle would look like, right like that. So we're going to create a reference triangle by drawing from this point straight up to the x-axis. And by drawing straight up, it'll hit the x-axis at a right angle. And I'm going to take that triangle and I'm going to figure out the measures of all 3 sides of that triangle. So the measure going to the left, since it's 3 units to the left, and since it is to the left in trigonometry, we would say that it does have a measure of -3. We can use negative measurements in trigonometry. And since this point was 4 units down, we can say that it has a measure on this side of -4. But then what's the measure of this diagonal side? Well, that side is the hypotenuse, so to figure out the measure of that side, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to figure out the measure of the hypotenuse. -3 could be our a, so that's -3 squared. Our b could be -4 squared, and that equals c squared. -3 squared is 9. -4 squared is 16 for 25. And then we would do a square root to figure out the measure of c. So c is going to equal 5. And a bit of a note here, the hypotenuse will always be positive. The hypotenuse, always positive. Why is it always positive? Because when we squared those negative numbers, we got positive numbers. And when we add 2 positive numbers together, we get another positive number. And when we take the square root, there we get +5. So now we're going to find the 6 trig functions of this reference triangle of this angle here that's nearest the origin using that triangle. So we'll have a sine, the sine of that angle, we'll call it theta. The sine of theta, the formula for sine is opposite over hypotenuse. The opposite side is the -4. The hypotenuse is the 5. The cosine of theta, the cosine is the adjacent over the hypotenuse. The adjacent side is -3. The hypotenuse is still 5. And then tangent. The tangent of theta is opposite over adjacent. So the opposite side is -4. The adjacent side is -3. And that would simplify, since it's a negative divided by a negative, to a positive 4/3. And then cotangent. The cotangent formula is adjacent over opposite. So the adjacent side is -3. The opposite side is -4. So that would simplify to 3/4. Secant of theta, formula for secant is hypotenuse over adjacent. The hypotenuse is 5. The adjacent side is -3. So that could be written as -5/3. And then cosecant. The cosecant would be hypotenuse over opposite. The hypotenuse, still 5. The opposite side is -4, and that could be written as -5/4. And remember, sine, cosine, and tangent all have reciprocal functions that are just the things, the measures flipped over. Tangent and cotangent are reciprocal functions, so notice that the answers are the reciprocals of each other. Sine and cosecant are reciprocals, so they're the reciprocals of each other, and cosine and secant are reciprocals of each other. Next definition is what's called a quadrantal angle. If the terminal side of angle theta in standard position lies on the x or y axis, we call it a quadrantal angle. So notice here, the terminal and the initial side are on the positive side of the x-axis. So that is a quadrantal angle of 0 degrees or 0 radians. When it's on the y-axis on the positive side, that makes a right angle. And being a right angle, it has a measure of 90 degrees or pi over 2 radians. Straight across the entire x-axis, that is a 180-degree angle, or pi radians. And then when we rotate 3/4 of the way around, that's 270 degrees, and 270 degrees is equivalent to 3 pi over 2. Remember, we can use pi is equal to 180 degrees to help us figure that out. So now that we know what a quadrantal angle is, 0, 90, 180, and 270, we can now figure out the measures, the trig function measures of 90-degree angles, 180-degree angles, 270-degree angles, and anything that's coterminal to that. So the terminal side of theta in standard position contains the point at 0, 6. Find the values of the 6 trig functions of theta. Well, remember what I said about a reference triangle is that on a reference triangle, if we would draw from that point straight up or down to the x-axis, that would create a reference triangle. The problem with quadrantal angles is by doing that, when you draw that straight down, you actually wind up right on top of the axis, and that doesn't appear to be much of a triangle. So what we're going to do is I'm going to kind of distort the triangle a little bit to kind of explain what's going on here. So here's a set of axes. And even though I'm trying to make a 90-degree angle, which would be straight up, so there's my initial side. Even though a 90-degree angle would be straight up, what I'm going to do is I'm going to kind of go off slightly. And the reason I'm going to go off slightly is because I want to show that there is a difference between this side and that side right there. Okay? They're going to have the same measure. So what that means is that the hypotenuse and this height is going to be the same measure, which doesn't seem to make a lot of sense with what you remember about trigonometry and geometry. But like I said, I've had to distort the triangle a little bit so I can show you the trig functions of a 90-degree angle. So since it said that this is at 0, 6, we're going to say that both of these measurements are going to be 6. Now, since I had to slide this point, this line right here out slightly, the length of this side down here at the bottom, we're going to say the length of that side is going to be 0. Because again, remember that this terminal side was right on top of the axis, which means that there would be no measurement here on the bottom side. This still does follow the Pythagorean theorem, because 0 squared plus 6 squared, if we call this 6 as my other leg, is still equal to 6 squared. 6 squared. So now that we've got the measurements of the three sides of our very strange looking triangle, we can now find the 6 trig functions of that angle right there. So the sine of that angle, which again is a 90-degree angle, the sine of 90 degrees is going to be the opposite side, which is 6, over the hypotenuse, which is 6, and that equals exactly 1. You can verify this with a calculator. If you type in the sine of 90 degrees, it will tell you that it is equal to exactly 1. The cosine of 90 degrees, so the adjacent side to our angle is the 0. The hypotenuse is still 6, and 0 divided by 6 is 0. You can also verify this on a calculator. If you type in the cosine of 90 degrees, you get 0 over 6, and it will tell you, the calculator will tell you it's exactly 0. And then the tangent of 90 degrees, that's opposite over adjacent. So the opposite side, remember we said, was 6, and the adjacent side is 0. Well, what's 6 divided by 0? Well, you can't do that, and so we actually would say that the tangent of 90 degrees is actually undefined. If you type in the tangent of 90 degrees, a scientific calculator will tell you it has a domain error. Then we can do the cotangent of 90. Remember, the cotangent is the reciprocal function of tangent. So instead of 6 over 0, we could say the cotangent is 0 over 6, which can be done. That's exactly 0. The secant is the reciprocal function of cosine. So the secant of 90 degrees would be 6 over 0. So I'm doing the reciprocal of 0 over 6, and that is undefined. And then cosecant is the reciprocal function of sine, and the reciprocal of 6 over 6 would still be 6 over 6, which is still 1. So the sine of 90 and the cosecant of 90 degrees are actually both the same, and they're both 1.